we are going to do something really special. We are going to do the AP Calc test that I took back in high school, and that's the one from 2004. Here we have the 2004 AP Calc BC free response questions. Unfortunately, College Board didn't release the multiple choice questions, but it's okay because we'll finish all 6 questions right here. We can use a calculator for the first 3 questions, but we have to do everything by hand for the last 3 questions. And before we start, I would like to tell you, this is the class that changed me forever because of the teacher I had. Thank you so much, Mr. Schneider. Thanks for all the challenges that you provide, and you made me want to be a teacher. I am a teacher now. Thank you. All right, let's get started. For the first question, we are given a function, and this right here represents the traffic flow during an intersection. Well, keep in mind that you notice f of t is measured in cars per minute. So this is actually a rate, but the notation for that is f of t. So I just keep that in mind. For the first part, we are going to find out how many cars pass through the intersection during this time period. Well, because this is a rate, once again because of the unit, that's a big hint. Well, all we have to do is just integrate this. So I'll just say, hey, let's integrate from 0 to 30. And then we just have to integrate the function, and then we'll just enter that, which is 82 plus 4 sine of t over 2, and then put on the dt. And for this one, we can just use the calculator. So enter this on your calculator, you'll get approximately 2,474, right? Round it to the nearest whole number, of course, because we're talking about cars. And that's it. So this is the first part. Okay, for part B, we're going to find out, is the traffic flow increasing or decreasing at t is equal to 7? Well, whenever you want to find out if it's increasing or decreasing, just go ahead and differentiate this, right? Because this represents the traffic flow. And then just plug in 7, and we can just see if we get a positive or negative first derivative. So let's go. First, f prime of t. Well, the derivative of 82 is just 0, and the derivative of this is 4 cosine, and then the input stays the same. But don't forget the chain rule, multiply by the derivative of the inside, and that's going to be 1/2 right here. So this is just 2 cosine of t over 2. And now just plug in the 7, f prime of 7 is just going to be 2 cosine of 7 over 2, and again use your calculator, you get approximately negative 1.873, right? So that's what we have, and now we have to answer the question. I will just say, well, let's put this down. Here is the answer. The traffic flow is decreasing at t equal to 7 because this because it's just, I think it should be okay, because the first derivative of the traffic flow function at 7 is less than 0, namely its negative first derivative. So this right here will be it. So this is how you can justify your answer. Part C, we are going to find out the average value of the traffic flow over this interval. So here's the deal. We just have to integrate this over this interval and then divide it by the difference of this and that. That's all. That's how we find out the average value. So let's just go ahead and get to work. We are going to integrate from 10 to 15, and then let's put this down right here, which is 82 plus 4 sine of t over 2, and then don't forget the dt. And one common mistake is that people forget to divide, right? So just keep that in mind. Divided by 15 minus 10, like that. And just enter this on your calculator, you'll get approximately 81. And in fact, this is the rate, right? This is an average value. So you can actually have decimal, so it's 81.899. Why is this a rate? Well, remember earlier when we integrate f of t, the unit's cars, but here we divide it by 15 minus 10, which is actually the time. So this is the rate. So it's actually 81.899, and the unit is cars per minute. Because remember, the unit for the traffic flow is cars per minute, and this is just the average version of that. So this right here is it. Alright, for part D, we are going to find out the average rate of change of the traffic flow over this time interval. This is very different, right? When we are trying to find the average rate of change, all we have to do is to find the slope between the endpoints. So go ahead and plug in 15 into the f of t. So we have f of 15, and then minus f of 10. So put down the 10 into here, right? So we have f of 10, and then divided by 15 minus 10. So here's the deal. The average rate of change is just the slope between the endpoints. That's all. And again, you can just plug in everything onto your calculator, and that will tell you this right here is approximately 1.518. In fact, it's just 0.1 away from the golden ratio. I think it's pretty cool. But anyway though, after the computation, you also have to include a unit. In this case, remember the top. When we have F, the unit for that is cars per minute. But then we divide it by minutes again. So this right here is just going to be cars per minute, but you have to have the second power here. So cars per minute square, and this is it. So for number 2, given this picture here, and then we also have the functions. Part A, we have to find the area of the shaded region. You know, it's a classic question. So we just have to integrate, and we go from 0 to 1. And then remember, it's the top function minus the bottom function, and the top function is this one. So we have 2x times 1 minus x, right? So this is the top function, and then minus the bottom function, which is the one in blue, namely the g function, which is 3 times x minus 1 times the square root of x. Perfect. And then of course, don't forget to put down the dx. And again, use a calculator right here, you get approximately 1.133. So that's it. Okay, for part B, of course, we are going to have a volume question. We are going to find the volume of the solid generated by rotating this shaded region about the line y is equal to 2. Well, y is equal to 2 is actually right here. So once you take this, rotate it like that, you see that the blue curve is actually on the outer piece. And let me give you guys a sketch real quick. So let's say we have the blue curve right here, and I will just kind of do a mirror image right here, like so, right? And here is the original x-axis, and of course we also have the y-axis here. And here is where the 2 is, right? So let me say this right here is where y is equal to 2. And now let's look at the f of x curve, like this. And once you rotate this about y is equal to 2, you will actually, again, just do a mirror image. And then at the end, you can just put like 2 ovals here, and that looks kind of like 3D, right? This is how I usually do it. Anyway though, as you can see, we have a solid, and the middle part is missing. So we just have to do what? Yeah, the so-called washer method, right? But it's nothing too scary. It's just pretty much the disk method minus the disk method, right? So how do we do it? Remember the volume of a disk, right? It's equal to what? It's just pretty much like a cylinder, right? You have pi r squared times the height. But a disk is so thin, so the height, I would just call that to be thickness. So this is what you have to keep in mind, right? This is the volume of a disk. Well, let's find out the outer piece first. What we have to do is, of course, the radius is the most important thing. And you will have to see the radius, because we are rotating like this, right? Rotating like this about the line y is equal to 2. So the radius, if you look at the picture that I'm about to draw for you, here we have a disk, right? And the radius is going to from here to here. And to find the radius, just remember top minus bottom in this case, in terms of y value. Well, let's put that down right here. I will put this down in blue. Pi is just pi, no big deal. Radius, square, we are about to make it happen. But notice though, the thickness in this case is what? It's just a small change amount in the x-axis. So this right here is going to be dx. And the radius is just the distance from here to here, vertical distance. Here we have 2, and then minus here. This is actually our y, right? The blue y value. And the blue y value is g of x. So I'm just going to write down g of x for now, right? So this is just 2 minus y, 2 minus g of x. And this is just going to give us the volume of the first disk like that. We have to integrate it from 0 to 1, so you can find out the whole thing. So of course, we'll just do that integral from 0 to 1. That's pretty much it. But again, we also have to take care of the middle piece. So we will have to subtract. And then for this one, we'll just integrate from 0 to 1. Again, pi is just pi. And then for the disk right here, I will try to draw another one. It's going to be like this. So it's just this part right here. And as you can see, the thickness is still dx. So I'll just put that down at the end. And we still have to find out the radius, which is again from 2 to here. And this is the y value in black. So I'll just put down 2 minus y. And our y value in black is actually f of x, which is just that, right? So I will just put down f of x like so. So that's pretty much it, the setup. And don't forget the square, by the way. This is pretty much a setup, and just enter everything onto your calculator. And remember, f and g are this and that, so just enter them into the calculator accordingly, and then we will get approximately, let me take a look, 16.179. Yeah, so that's it. Part C is also a volume question, but it's not the volume of the solid of revolution. Rather, we have to do it with cross-section. Check this out. We are given h of x, which is not shown right here. And the equation is k times x times 1 minus x, and k is positive. So I can expect that h of x looks like f of x because they are going to be both like parabolas. Anyway, the region enclosed by h and g is the base of a solid with square cross-sections perpendicular to the x-axis, and we know the volume is going to be 15. And now we are going to set up an integral. For that situation, we don't even have to solve for k, so that's pretty cool. So now let me just give you guys a picture for h of x and also g of x. And again, as we talked about earlier, h of x is going to look like this kind of shape, but we just don't know how high it goes because we don't know the k value. So I'm just going to put a curve like this, and again, this is h of x from 0 to 1. And now we of course still have the g of x, and it looks like this. Pretty good. So this time, this right here is the base of the solid, and we are going to build up squared like this. So that's going to be how the solid is going to look like. I know this kind of thing is really hard to imagine. I will try to draw a 3D picture for you guys. And the way that I do it is I kind of just tilt this a little bit. Check this out. Here is my x-axis, and I'm going to draw the y-axis like this. And then of course we have the 3D picture, so we have the z-axis like that, but let me not do it. Anyway, h of x is going to look like this now, somewhat like that. This is h of x, and we still have the g of x right here. So this is the g of x, right? It's a little bit more curvy right here. Well, what we are going to do is we are going to build up, but use this as a base and then build up squares like so, right? So I'm going to draw a square like that, and in fact it has a thickness. So I should do it like this, and then of course you have to build it up and then build it up. It's like a book, pretty much like a square book. Yeah. And just use the idea. Volume is pretty much the integral of areas, and the area has a small thickness. That's pretty much it. And as you can see, this right here is just going to be dx because it's perpendicular to the x-axis. And now we just have to find out what's this times that, right? Because that will give us the volume of this book. So you can see, this is pretty much what we did earlier. The distance from here to here is going to be this side, which is just h minus g. That's all. So here we go. The volume is going to be, well, we have to integrate from 0 to 1, right? This was going from 0 to 1. And what we'll do is we have the dx all the way at the end. And now, again, we have to do h of x minus g of x. So I'll just put this down. H of x minus g of x. So this right here is the side of the square, and then we just have to multiply by itself, right? To find the area of the square. And yeah, we can just put this down to the second power. Yeah, the area of the square is just side times side, so that's what we have. And if you multiply by the dx, that's how you get the volume of this red book. And we are just going to be plugging the h function here and also g function here, and that's pretty much it. This will calculate the volume of this shape. Let me, just probably put down a couple more of this right here, and you can see that it's actually like a, yeah. If you kind of just imagine, it's actually like a solid. And the volume for that thing is going to be 15. And this is what the question is asking. And all you have to do is just box this now. Can you solve for k? Yeah, but the question didn't ask you to do so, so leave it like that. That's it. Okay, for number 3, we're given the position x of t, y of t, but we only know dx dt is equal to this. We do not know dy dt. However, we do know that when t is 2, the position is at 1, 8. Okay, so part A, we are going to find the x coordinate when t is equal to 4. Well, in notation, this means we are going to find out what x of 4 is. Well, earlier when t is 2, we know the x coordinate is equal to 1. So we must start from there, right? So let me just put down x of 2. And again, this is 1. I would like to know what happens from t is equal to 2 to t is equal to 4, right? We need to find out that change. And how can we find that change? Yeah, we can just use this. And we have to integrate it. All we have to do is just integrate from 2 to 4 of the derivative, because that will tell you the change of the value from 2 to 4, right? In terms of the x value, x coordinate. So that's pretty much the idea. And let's just put that down. 3 plus cosine of t squared dt. And let me just tell you, this is going to be 1, right? And you will have to use a calculator. There's no way for you to integrate this by hand and get a nice decimal. But anyway though, this will be approximately 6.133. So altogether, x of 4 is approximately 7.133, right? X of 4 is approximately 7.133. So that's the first part. Part B, we are given that when t is 2, dy dt is equal to -7, and we are going to write an equation of the line tangent to the curve at this point, which is just that. So of course, we need to get the slope. And yes, the slope is the derivative, but you have to remember we are dealing with a parametric equation situation, right? This right here, the derivative is dy dx. How can we get dy dx though? Yes, for the parametric equation situation, we do dy dt and then over dx dt. And we just care about when t is equal to 2. Well, thanks to this right here, we know this right here is just equal to -7. And when t is 2, we can just put the 2 right here to get dx dt. So we get 3 plus cosine of 2 squared, and of course use your calculator, you will get approximately 2.983. So that will be the slope that we'll use. Well, let's go ahead and use the point slope 4. I think that's my favorite one. Namely y minus y1, and that's equal to the slope, and I'm just going to write down m, and then we have x minus x1. So of course this is going to be the x1, which is just equal to 1. And this is going to be the y1, which is 8. Because this is the point that it was given. So here we have y minus y1 is 8. And then the slope is that. We can just put down 2.983 and then multiply by x minus x1 is just 1. So this right here, we'll do it. For part C, we're going to find the speed of the moving particle when t is equal to 2. And remember from the previous part, dy dt is equal to -7 when t is equal to 2. So for the speed, when we are working with parametric equations, this right here is just going to be square root. And then you pretty much square the velocities and then you just add them up and throw inside, right? So for the dx dt, I'm going to write it as x prime of t is equal to 2, right? It's easier for us to write it down like this. And remember, we are going to square this right here and then add it with y prime of 2 and then square. And then just do the work. This right here is equal to the square root. X prime of 2, we can just put a 2 in here, so we get 3 plus cosine of 2 squared, and then we are going to square that. And then this right here is just equal to -7, so we have -7, and then we square that. Again, use the calculator to do this. You get approximately 7.383. And according to the answer key, you don't have to put down the unit because the unit was not given. So this is it. But remember, this is the speed, so if they have unit, then it will be distance over time. Yeah, so that's part C. Okay, for part C, we know that when t is greater than or equal to 3, the line tangent to the curve has the slope of 2t plus 1. And we are going to find the acceleration factor at t is equal to 4. And what that means is that, well, in notation, it's just x double prime at 4 and also y double prime at 4. And to do this, it's not so bad because we have the first derivative right here already, right? So let me just write that down. That's the same as writing x prime of t, which is equal to 3 plus cosine t squared. All right, differentiate this again. So x double prime of t, this will be, okay, that will be 0. And the derivative of cosine is negative sign. And then the input stays the same, but we differentiate this, right? Because of the chain rule. So we have 2t. And now just plugging 4. So we get x double prime at 4. This will be -2 times 4. And then sine of 4 squared. And again, use your calculator. This right here is approximately 2.303. So that's it for that. But now, how can we figure out y double prime though? It looks like we still have to do some derivative, huh? But we don't have y prime at all. Well, we are going to use the idea that we did earlier. Remember, when we have dy dx, right? When we have dy dx, this right here is the same as saying dy dt divided by dx dt. And you know what? We know dy dx is this. Why? Because it says so. Tangent line, right? And it has the slope 2t plus 1, right? And this is just at some t. So we know that this right here is 2t plus 1, and that's going to be equal to, well, dy dt we still don't know yet, but we do know dx dt is just equal to that. So it's just going to be 3 plus cosine of t squared. Of course, now we can just multiply this on both sides. And dy dt is precisely the y prime that we want. So this is equal to 2t plus 1 times 3 plus cosine of t squared. Okay, here we can just do the derivative. So let's see. Here we have to do the product rule. So I'm going to keep the first function, which is 2t plus 1 times the derivative of the second, which is just that. So we'll just put this down right here in red, right? So we get -2t sine of t squared. And then I'm going to keep the second function. I will just put it down right here. We add 3 plus cosine of t squared. And then we multiply by the derivative of the first, which is just going to be a 2. So multiply by 2 right here. Okay? And I'm going to let you guys plug in the value because I'm about to run out of space. But if you do y double prime and then if you plug in 4, this right here is going to be approximately, right, you enter the 4 in there, you get 24.814. So finally, we have the answer now. It's just going to be 2.303, 24.814. Yeah, so this right here will do it. Yeah, that's it. Now moving to the non-calculated part of the test. Number 4, we are given this equation here and we are going to show that dy dx is equal to this. And this is actually really nice because you know you should end up with this, otherwise we'll be wrong, right? And by the way, I really don't remember any of these questions. I actually remember number 5, but not this one. But anyway, though, here we go. I'm just going to do implicit differentiation. So let me just write that down again. So x squared plus 4y squared equals 7 plus 3xy. And usually I would like to put down dx here. Again, implicit differentiation. The derivative of x squared is just going to be 2x. And the derivative of this, bring the 2 to the front. So we get 8, right? And then minus 1, so we have y to the first. But y is a function of x. Here we have to multiply by dy dx. All right, on the right-hand side, the derivative of 7 is 0, and the derivative of 3x times y requires the product rule. I'm going to keep the first function, and the derivative of y is dy dx, so multiply by that. And then we add it with y times the derivative of the first. The derivative of 3x is 3, so I will just put down 3 right here. Okay, now I'm going to move this to the other side, and I'm going to move this to here. So as you can see, once we put this right over there, both of them will have the dy dx. We can factor that out. So let me put down parentheses 8y, and that will be negative 3x, and then we factor out the dy dx right here. And that's going to be, here we have 3y, y, and then that's 2x, right? And then once you bring 2 here, it's minus 2x. And of course, in the end, we can just divide that on both sides. So ladies and gentlemen, we have dy dx being equal to 3y minus 2x over that 8y minus 3x, which is exactly what we have over there. Just for fun though, let me tell you, because here we have subtractions, and it really depends on how you move things around, right? Sometimes if you move things around in a different direction, let's say if you bring this to the other side, and then you bring that to there, well, this is equivalent to say 2x minus 3y over 3x minus 8y. Why? We can just multiply the top and bottom by negative 1. So that's pretty much it. But just leave it like that because we want to show that. Okay, continue. Here we have to show that there is a point P with x coordinate 3, and we know that the tangent line over there is horizontal, and we also have to find the y coordinate of P. Okay, so here remember this is our derivative, and horizontal tangent line means dy dx is equal to 0. So let me just put down the derivative right here. Dy dx is equal to that, which is the 3y minus 2x over 8y minus 3x. Notice the derivative is based on x and y, right? But don't worry, x is given already. So first, let's go ahead and set this to be 0 because we want the horizontal tangent line, right? So as you can see, if we have a fraction that's equal to 0, all we care about is just this, the numerator. If the question says vertical tangent line, then you care about the denominator, right? So this right here tells us we just have to set 3y minus 2x is equal to 0, and it says x is equal to 3. So let me just say let x equal to 3, plug into here, we get 3y minus 2 times 3, and that's equal to 0. And of course that's 6, we can just bring that to the other side, so we get 3y is equal to 6, and we can see that y is equal to 2. So in fact, that's pretty much it. But we do have to show the following though. We do have to make sure that 3, 2 is actually on the curve. So that's the key. So I'll just show that right here, right? 3, 2 is on the curve. Because, well, this is the x value, this is the y value, just plug in and just do the work. So let's see, plugging 3 into x, we get 3 squared plus 4 times 2 squared, and that's equal to 7 plus 3 times 3 for x, and then 2 for y. We don't know if this is true or not. Because remember, what if this wasn't, I don't know, like, because, yeah, we just have to do it. Anyway, let's see. This right here is 9, and then plus this is 4 plus that is 16, all right? So is this the same as 7 plus 9 and then 18. Have a look. This is 25 equals 25. So it works. You see, here's the trick. You can do all this and you might end up with 3, 2. But if this 7 was, let's say, 22, then you have the 22 here, then in fact that point is not even on the curve. But anyway though, this is how you're supposed to do this question. That's how once you show this, then you are done. Okay, so for part C, we are going to find the value for d2y dx2 at the point P, and we also have to see if it's a local minimum or maximum or neither, and justify the answer, right? So to do this, of course, we have to differentiate that. So let me put that down. d2y dx2, it's the same as differentiating this, which is 3y minus 2x over 8y minus 3x. For this, we will have to use the quotient rule. So let's go ahead and get the fraction ready. And we have to square the bottom. So let's go ahead and do that, just in case we forget. So we have 8y minus 3x, and again, square that. And the quotient rule says, go ahead and put out the bottom function, which is 8y minus 3x, and then we are going to multiply by the derivative of the top function. Derivative of 3y is going to be 3, and you write down dy dx, right? The derivative of y is dy dx. And then the derivative of negative 2x is just negative 2. And then minus the top function, which is 3y minus 2x, and then we multiply by the derivative of the bottom, which is going to be 8 dy dx, and then minus 3. So that's what we have, and that's pretty good. So this is what we have, and you see, here we have the point P, right? So we're just going to evaluate this at P, which is 3, 2, and this tells us x is 3 and y is equal to 2. But what's dy dx? Remember, at point P, dy dx was equal to what? 0. We saw that earlier. So at this, dy dx is equal to 0. So we can say this right here is equal to 0, this right here is equal to 0. Very nice, huh? And let's just go ahead and set this up. So here we have what? 8 and y is 2. And then minus 3 times 3. All right, and then this is 0, so we just have to multiply by negative 2. And then minus, and then we have the 3 times 2. And then minus 2 times 3. And then that's 0. And then we just have minus 3. And then over, whoa, this is let's see, 8, and then y is 2, and then minus 3, and then x is 3, and then square. And you're supposed to do everything by hand now because this is the non-calculated part, right? And I will trust you guys that you guys cannot do all this. So just tell you guys that after you have all that, the answer is negative 2 over 7. Right? So this right here is the value for d2y dx2. So now, do we have a local minimum, local maximum, or neither at P? Well, remember, you see, dy dx is 0, and the second derivative, like d2y dx2, is negative. So it's like 0, right? The first derivative 0 is horizontal, and this tells us it's concave down. Therefore, we have a maximum. So I will just say there is a local max at the point P. Here's the reason. Because we have dy dx being equal to 0. So I'll just say dy dx is equal to 0. And d2y dx2 is negative. So concave down, you get a local max with the first derivative being equal to 0. So that will do it. Okay, this is the question that I still remember because I remember this is the one that got it wrong. And it's not even a hard question. Check this out. Here we have a differential equation, and this is actually a logistic differential equation for some population. And for part it says, if P of 0 is equal to 3, then what's the limit as t goes to infinity of p of t, right? Well, this is a logistic differential equation, and in fact, if you look at the 12 right here, this is exactly the carrying capacity. What does that mean? That means it's the limit. It's the answer already. So right here, if you just put on 12, this is it. Why? Why 12 though? Well, here's the deal. When p is equal to 12, if you put it here and here, you can see that 1 minus 12 over 12, that will give you 0. And you see that dp dt was equal to 0 when p is equal to 12. That means you don't have change anymore in the long run. It doesn't really matter what the starting is. For this right here, you get 12. If p of 0 is equal to 20, in fact, you will also get 12. I still remember what I did. I have 12, and then at the 3, I put on 15. I had the 12, and then I put on the 20 as well. Altogether, I put on 32. Don't do that. Yeah, don't do that. It's just 12. Why did I do that? I don't know. Alright, for this question, it's just as easy as the first one. If you remember and understand what does the logistic differential equation do. Well, if p of 0 is equal to 3, then it says for what value of p is the population growing the fastest? Well, earlier we talked about it, the carrying capacity is equal to 12. Well, in fact, to answer this question, all you have to do is take half of that, so the answer is just equal to 6. Whenever you have a logistic differential equation, when you have half of the carrying capacity, then that's the time that you grow the fastest. That's all. You can just put down 6. And if you check the answer key, yeah, you just write down 6. That's it. You don't have to write down too much. For part C, they actually gave us another differential equation. We have dy dt that's equal to y over 5 times 1 minus t over 12. This looks similar to the earlier one, right? But it's actually easier. Check this out. Earlier we have p, p, and p, and right now we have y, y, and t. This is the independent variable. It's easier to solve for y of t right here. So they gave us an easier one, and we are solving for that when y of 0 is equal to 3. To do this, we will have to do partial fraction, and then the procedure is slightly longer. So, thanks to the writer for that. Anyway, to do this right here, we can just separate the variable. We are going to divide the y on both sides and multiply the dt on both sides. So here we get 1 over y dy, that's equal to, here we have 1 over 5, multiply with 1, we get 1 over 5. 1 over 5 times negative 1 over 12, we have negative 1 over 6t. And then let's put a t right here and put a parentheses because I will have to multiply the dt here. So that's what we have. Now, let's just go ahead and integrate both sides. On the left-hand side, we get natural log absolute value of y. You don't have to put on the plus c because just do it on the right-hand side, that's enough. And right here, integrating 1 over 5, in the t world, we get 1 over 5t. And then this right here, you add 1 to the power, which is t squared, and divide it by that, so we get minus 1 over 120 t squared. And here, let's put down the plus c1. And then now let's just do the work. E to that power and e to that power. So you see that this and that cancel, and we get the absolute value of y that's equal to, well, e to this function part, I will just keep it as how it is, which is e to the 1 over 5t minus 1 over 20t squared. And then we multiply by e to the c1 right here, right? Because of the rule of exponents. But e to the c1 is the same as just a constant, so I'm just going to write that in front, and I'm going to label that as c2, like that. Well, here we have the absolute value. Let's just get rid of it. But we are going to put a plus or minus on the right-hand side. So you see, here we have y, and we are actually done isolating the y, so I'll put this down as y of t. That's equal to, we have the plus or minus c2. That's just a constant, so I'm going to write that as c3. And in fact, you don't have to put down the c3 anymore, you can just write down c because that's the final result for the general solution. And then I'm just going to write down e to the 1 over 5t minus 1 over 20t squared. Okay, general solution. And when we have y of 0 is equal to 3, let's see, y of 0 should give us 3. This means, putting 0 in here, we get c e 1 over 5, and then 0, and then minus 1 over 20, and then again 0. Square, this right here should be equal to 3. This right here is just 0, and then we have e to the 0, which is just 1. So it's just c is equal to 3. Very nice. So finally, let's just put everything together. Y is equal to 3, and then e 1 over 5t minus 1 over 20, and then t squared. And ladies and gentlemen, this is it. Okay, for part D, we are just going to calculate the limit as t goes to infinity of y of t, which is this one that we got here. Well, this is just the same as take the limit as t goes to infinity, and here we have 3e to the 1 over 5t minus 1 over 20, and then t squared. Well, as t goes to infinity, here we have e to the infinity, and then minus, this right here is infinity squared, right? This right here dominates that. So in fact, the whole power here becomes negative infinity. So what we do is, well, this right here is just going to be 0. And again, on the answer key, if you just have this and then put a 0, that's it. Okay, for number 6, of course, we have a series question. Here we have the function f of x is equal to sine of 5x plus pi over 4. And p of x is equal to the third degree Taylor polynomial for f at 0. First part, we are going to write the expression for p of x. So let's just go ahead and get to work. And I will recommend you guys to just use the Taylor formula. So let's make a table to organize all our computations. So we have to differentiate this a couple times. And the last column is the Taylor formula. So let me just put that down. And we know the center is at 0. So I will just put down the 0 right here. And then don't forget we still have to divide it by n factorial. And we just want the third degree, right? So we will just go to 3. So let's see, 1, 2, 3 lines, and then n start with 0, 1, 2, 3. Okay, the zero's derivative is just the function itself. So I'll just write down this is sine of 5x plus pi over 4. Well, differentiating this, don't forget the chain rule, right? The derivative of 5x is 5. So you have to multiply by 5. Therefore, you get 5, and then you have the cosine, and then this is 5x plus pi over 4. And then just continue. Next, you get negative sine, and then the input stays the same. But 5 times 5, we get 25 here, right? And then just do it again. Put a 5, right? Multiply with that. So we get negative 125, and then becomes cosine, and then we have 5x plus pi over 4. All right, now we are going to plug in 0 into this. So we just have sine of pi over 4. And that's what? 1 over square root of 2. Or if you prefer, you can just write it as square root of 2 over 2. And then divide it by 0 factorial, right? And then you can just continue. Put a 0 in here, cosine of pi over 4. It's also square root of 2 over 2. But don't forget we have the 5. So I will put down 5 square root of 2 over 2 and divide it by 1 factorial. Here we have negative 25, and then square root of 2 over 2, and then divide it by 2 factorial. And then lastly, do the same thing. So we have negative 125 square root of 2 over 2 over 3 factorial. And I don't think you need to simplify anything. You can just leave it like this. So finally, I'll just write this down for you guys. We'll just say p of x, this right here is equal to this first term, which is just square root of 2 over 2. And then we are going to add it with next, which is 5 square root of 2 over 2 times 1 factorial. Doesn't really matter. But you have to make sure you multiply by x minus 0 to the first power, right? And then we'll continue. We are going to subtract. Here we have 25 square root of 2 over 2. But this is 2 factorial, so depends. You may want to just write it as 2 right here and then 2 factorial here. Then I think that's okay. And this is going to be x to the second power. Lastly, we have the minus 125 square root of 2 over 2. And then we have the 3 factorial. Let's just put that in the front. Like this. And then multiplication. And then x to the third power. And there we have it, third degree Taylor polynomial for p of x. So that's that. Okay, for part B, we are going to find the coefficient of x to the 22nd power in the Taylor series for f about 0. So here's the chart again. And as we can see earlier, when n is equal to 3, this right here gives us this coefficient and then x to a third power, right? So yes, we can just keep going until we reach n is equal to 22. No, don't do that, of course not. Let's look for a pattern. But we do need to get the 22nd derivative of f, right? But one thing to note is that the derivative sign is cosine, and if you do it again, we get negative sine, and then we get negative cosine, and then next we get sine, and then cosine, and then so on, so on, so on. So these are the fundamentals. And all we have to do is the following. Look at 22, and then we are going to divide it by 4 because it's every 4 times. This right here will give us 5, but the remainder is equal to 2. So what does that mean? That means we can just match with this right here. Because 2 divided by 4, the remainder is 2. So you are going to pay attention to the negative and then also the sign. The 22nd's derivative is going to be negative, and we have the sign, and then we have 5x plus pi over 4. But wait, we still have to do the chain rule, right? How many times? Altogether, 22 times, right? So you will get 5 to the 22nd power, just like that. Alright, so this is the 22nd's derivative, and if you want to get the coefficient, of course you can just put a 0 in here, and that's pretty much it. So I'll just write this down, 22nd, and then if we put a 0 here, and don't forget to divide it by the factorial, right? 22nd factorial. So this is going to be negative 5, and then this thing is again going to be square root of 2 over 2, and let me make the negative in red as well, so match with that. And then divided by 22 factorial, and if you would like, we can put this in a nicer way, well, 22nd power. We have negative 5 to the 22 power square root of 2 over 2, and then here we have the 22nd factorial. Yeah, so this right here, we'll do it. Okay, for part C, we are going to show that this inequality is true. And you know what? In high school, I didn't know how to do this. And you know what? I still don't know how to do this. So let's move on to part D. Okay, this is the last question. Here we are going to have g of x. Of course, just kidding. I looked at the answer already, right? Come on. All right. I did look at the answer though. Anyway, Lagrange error bound. That's the key, which says the absolute value of Rn, and the R is the remainder, and the n in our case is 3 because p of x is the third degree Taylor polynomial. And this says it will be less than or equal to the absolute value of x minus c. What is c? C is the center of the Taylor polynomial, and in our case right here is 0. Some textbook may use a, right? But you have to know that that's the center of the Taylor polynomial. All right, we have this raised to the n plus 1 power and then divided by n plus 1 factorial, and we are going to multiply by the maximum of the fourth derivative in our case. Well, actually, let me write down the formula. It will be 1 more than the n. So f, and you just have to differentiate it 1 more time than whatever this n is, but in our case, it will be the fourth derivative. And you just do this right here. And you have to make sure that for all x in between of 0 to the x value that we care, which is 1 over 10. So that's what we have, okay? So you have to make sure that this ranges. And sometimes this might be confusing because we are about to plug in 1 over 10 to x, right? So sometimes people might put down like a different letter here. Maybe let's say t. Yeah, so just like that, okay? Anyway, this is how we are going to do it. Well, why am I using blue? For this right here, it's not so bad at all. You can see that x is 1 over 10 because that's our input, okay? So here we have absolute value of 1 over 10, and let me just say x is equal to 1 over 10. 1 over 10 minus the c is 0, and then the n is equal to 3 as we mentioned earlier. So we have 3 plus 1, which is 4, and over 4 plus 1, and then we factorial, 3 plus 1, and then factorial that, and then we have to find the maximum, right? The maximum of our fourth derivative. If we differentiate this one more time, we will get past the sign, right? And then this is going to be 5 to the fourth power, and it becomes the sign right here, and then we have 5x. Actually, I use t right here, so I'll use t, and then plus pi over 4. And this quantity is just trying to get the maximum of the fourth derivative. That's all, right? So you have to do this on the calculator also. But you know what? This is actually not so bad. You know why? Because the maximum right here, the maximum of sine, cosine, whatever, the maximum here is 1. So I can say this is always less than or equal to 1. So here we just have to consider 5 to the fourth power and then all that. So let's see what do we have. So this is going to be less than or equal to, because I will have to use this. So let me put down blue right here. So we have, this is 1 over 10 to the fourth power, and then we will have 1 over 4 factorial, and this is multiplying by 5 to the fourth power. And let me just put down the 1 right here because I use that inequality for this, right? So now we just have to compute this. So 1 over 10 to the fourth power is 1 over 10,000, and then 1 over 4 factorial is 1 over 24, and then 5 to the fourth power is just, let me write it as 5 times 5 times 5 times 5, because it's easier to reduce this, and that is 2,000, and then 400, and then 80, and then 16. 16 times 24, let's see, 16 times 24, this is going to be 64, and then 16 times 16, 16 times 2, which is 32, so altogether 384. Anyway, altogether we have 384 on the bottom, and this is equal to, because it's just a computation, 384 on the bottom. And you know what? This is definitely less than 1 over 100. So that's it. Okay, this is the last question. Here we are going to have g of x is equal to the integral going from 0 to x, f of t dt. And we are going to write the third degree Taylor polynomial for g of x. We're going to finish this strong. Check this out. This right here is equal to the integral going from 0 to x, f of t. Well, let's just get the polynomial for f of t. Instead of using x, we're using t, that's all. And in fact, we did that earlier for p of x, right? But we are not going to write down the whole p of x, because p of x was third degree. If we integrate third degree, we'll end up with fourth degree. That's no good. So just look back to part A, and we're going to write down the first 3 terms up to degree 2. And then instead of the x, we are going to put down t. That's all. So this right here becomes square root of 2 over 2. That's a constant term. And then we add 5 square root of 2 over 2, x to the first power, and then minus 25 square root of 2 over 2, but multiplied by 2 factorial. So that's 4, and then x to the second power. And again, I made the mistake. I just told you, we don't want to use x. We are going to use t. Right? And then here we have the dt. And just integrate this. Well, we get what? This is square root of 2 over 2. Technically, right now it will be t. And then plus 5 square root of 2 over 2. But you add 1 and you divide it by the new power. So you have another 2 right here. And then it's t squared. And then you add 1, which is 3. And you divide it by that. So you have minus 25 square root of 2 over, again, the 3 here. And then multiply by 4. And then t to the third power. Just like this. Finally, oh my goodness. Just kidding. 0 to x. You're plugging x into all the t's and then plugging 0 into all the t's. Finally, we get square root of 2 over 2x plus 5 square root of 2 over 4 x squared, and then minus 25 square root of 2 over 12 x to the third power. Plugging 0, you just get all 0. there's no plus c because this is actually a definite integral. So, ladies and gentlemen, hopefully you guys all enjoyed today's experience, and this is the AP Calc BC test I took, oh my god, over 17 years ago. Seriously? It has been that long? Wow. I was exactly half of my age. So this is special, isn't it? Alright, if you guys have any questions, leave it in the comment down below. Thank you guys for watching, and as always, that's it.